Greetings, welcome to my second video on the solutions for Module 4, and we're starting here with number 6. They're asking us to construct a probability distribution for this experiment. It's an experiment of a woman wanting to adopt 4 pets, and they'd be cats and dogs. And the moment you hear that, you know this is an experiment that has 2 outcomes, and let's not pay attention to what it actually is. So you just look at the outcomes. It's 4 outcomes, 2 outcomes, sorry, either dog or cat, and 4 pets. So this is a dual outcome experiment, which looks just like its construction. It's going to be exactly similar to the one you would do for 4 coin tosses or 4 gender sequencing. It'll be the same thing. Now, as you've read the PowerPoint, you'll see and you've noticed that there are 2 ways to do it. I called it method 1 and method 2. It's the long way to do it, and it's the short way to do it. It's your call. So if you don't want to do the Pascal triangle, then you want to do method 1. You just want to use this sample space. So obviously, in order to do that, you have to construct the sample space for all cats and dogs. The first, this is the tree diagram, cat and dog, and then cat and dog again. So you do it for 4 pets. And you list the outcomes, cat, 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 dog, and so on. And then you basically count and fill out this table. Now, what are the number of possible outcomes you can have? Let's see what are they looking for here. It says consecutive probability number of cats. Okay, so the thing is number of cats, all right. What are possible number of cats we can have if you want to have 4 pets? You can have none of them being a cat, 1 of them is a cat, 2 of them are cats, 3 of them are cats, or all 4 of them are cats. Now, how am I going to figure out these probabilities? Well, you just have to come to this table and start counting it. How many of these out there? 16 of them here if you count. How many of these have 0 cats in them, which means it's just dog, 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 dog? Well, there's only 1 out of 16. 1 out of 16, that's what's going to go in the first box. How many of them have 1 cat in them? So if you count, how many of them have 1 cat? This has 1 cat in it. That's 1 outcome. That's 2 outcome. That's 3. And look for 1 cat outcome. That's 4. And none of them have 1 anymore. So it's 4. So the second one will be 4 out of 16. And then the next one, if you look at it, it says how many of them have 2 cats in them. If you count how many of them have 2 cats in them, you'll see it's 6 of them. How many of them have 3 cats? If you count all the 3 cat ones, you'll see it's 4 out of, there's 4 of them. So it'll be 4 out of 16. You can count to verify. And the last one, how many of them have 4 cats in them? Well, the only one that has 4 cats in it's only 1 outcome, so it's 1 out of 16. So that's it. And that's how you figure out these probabilities and their denominators. Now, that's the long and hard way to do it. The easier way to do it, I would think, would be to just do the Pascal triangle and use the formula that says, okay, how do you figure out the total number of outcomes? It's just 2 to the power of n, but n is 4 here, so it'll be 2 to the power of 4, which is 16. So it's easy for me to know the denominator is 16. I don't need to construct all of this and take an hour to do it for me to just figure out there's 16 outcomes, right? Okay, so I know the denominator. And the numerator, all you have to do is do the Pascal triangle and go to the one that has a 4 in it. And those are the numerators, 1, 4, 6, 4, 1. And that's what it was when you did it manually. So you could very easily do this in like 10 seconds by just simply memorizing the Pascal triangle and knowing that the denominator is always 2 to the power of n when n is the number of pets or coins or gender sequencing you want to do. So you just type 1 over 16. That'll be the first probability. The second one is 4, so it'll be 4 out of 16. The next one is 6, so it'll be 6 out of 16. The next one is 4, so it'll be 4 out of 16. And then 1 out of 16. So it's just so much easier to do it with Pascal triangle than to try to do it with the tree diagram here. All right, let me erase all the write-up. Okay, so now it's asking us to calculate the mean and the standard deviation. All right, and we'll do that. Let me just move that a bit away. If I can do it. No, it's been embedded, so I'll just have to do the stuff here. I don't have any room for So at this point, you notice that my Excel has frozen, and that happens to you guys. It happens to everyone, so you kind of want to get out of it and then get back into it. That happens. So let me get back into it. You can get back into it from your actual file on wherever you saved it. It's good that this happened, so you can see it happen to all of us. It happens. All right. So, see, now I can move it. There we go. So let me move that away so I can calculate the mean and the standard deviation. And remember, every time they ask you to calculate the mean and the standard deviation, you have to calculate the variance first before you calculate the standard deviation, even if they don't ask you for the variance. Just remember that. All right, let's create our two columns that we need to calculate the mean and the standard deviation, or the variance. XP's is basically X times P. X squared P is X squared times P. And if I drag them down, select both of them and drag them down, there is my XP's and X squared P's. Now I have to add them, correct? Let's change the color. Let's add them. And those are my sums. Now my mean is going to be simply this 2 here. Again, remember, I'm not going to calculate the standard deviation next. I'm going to calculate the variance, even though they haven't asked me for it, but I need that in order to calculate the standard deviation easily. And the variance, as I told you guys, is the second number minus the square of the first number. Variance is 1, so thank God. The standard deviation is the square root of 1, which is 1. But I'll just do it anyways. And there's the mean and the standard deviation for number 6. Let's move on to number 7. Here's a game. The two things happening here. You're either winning or you're losing. So it's a 2-row, it's a small probability distribution. So it says you win $1.50 if it shows heads, and you lose $2 if it shows tails. These are net prices, net winnings. So let's see. I win $1.50, so 1.50 is a positive, or I lose 2, so minus 2. Okay, and it's heads and tails, so each one is 0.5, 50-50. It's a fair coin. All right, there's your probability distribution. It's pretty straightforward. Now it says, well, constructed it, I just did. And now it says calculate the expected value. Well, in order to calculate the expected value, I need to create a column of XP's. Which is X times P. Drag it down. It's just one operation. Very good, and that's it. And add them up. So there's the sum, and that is the expected value, which is sum of the XP's. So that's just equals negative 0.25. And there is my expected value. So negative 25 cents is the expected outcome in the long run. Okay, let's move on to number 9. Same as number 6. It's a 2-outcome experiment, boy-girl. Again, whether it's a boy-girl or a cat-dog or a coin toss, heads, tails, they're all the same from a mathematical point of view. What do you have? 5 children. So here I could just do this the way I told you to do it. So 5 children, so it's 2 to the power of 5, which is 32. So I know my denominator is going to be 32 here. And I know my value is 5 children, so it's 0, 1, 2, 3, 4, 5. So those are my values for x. And my probabilities, I know the denominators are all 32. And since it says 5 children, I go to the row after the one that starts with a 5. It's right here. So it's 1, 5, 10, 10, 5, 1. You see how easy it is when this is in front of your eyes and you know the total number of outcomes? That's it, and those are your probabilities. So let's construct it. 0, 1, 2, 3, 4, 5. The probability for 0 is this first number divided by the total. Well, I can't select the number, so it'll just be 1 out of 32. The second number is 5, so it'll be 5 out of 32. So simple to do it like this. The third number is 10 out of 32. So it just, you just bypass the need to do a tree diagram, to sit there and count all these within those 32 outcomes. It's just a pain. It's just so much easier to just memorize this table, this Pascal triangle. You don't even have to memorize it. You could every time construct it and just memorize this formula 2 to the power of n for you to figure out the denominators, and you're done. 10 out of 32, and then the next one is also 10 out of 32. And then the next one is 5 out of 32. And the next one is 1 out of 32. And if I want to know if I'm right, I could just add these up to make sure it's a 1, so I know I've done it properly. Yeah, I did it right. Excellent. So there's my probability distribution again, as always. Let me erase these. Alright, so now it wants us to calculate the mean and the standard deviation again. In order for you to calculate the mean and the standard deviation, first you want to calculate the variance before you calculate the standard deviation. But before all of that, every time they ask you for that, you have to create those two famous columns that you need the data for to actually do this. Those are the xp's and x squared p's. By now that should be engraved in your memory. So let's calculate the xp's, x times p. And here it's x squared times p. And then you drag it down, both of them. Easier to do this on a PC than an iPad, but I'm trying. It didn't work out for x squared p's, so I'm going to try this again. X squared times p. And let's drag that down. Hopefully this time it will work. Yes, it works. And this one is correct. Yes, so let me add these together. Change the color. Bold them. There we go. So the mean, the expected value, will be 2.5. And then I first again go and calculate the variance, which is the big number minus the smaller number next to it squared, always. And then once you calculate that, then the standard deviation would just be the square root of that number. And there's the standard deviation. And again, as far as the number of decimal places are concerned, you'll be instructed as to how many decimal places to leave on the exam. Alright, that's number 9. Let's look at number 10. Again, it's a dice game here. You have, looks like you have 2 outcomes. You have a $5 wager, that's the bet. You win $8 net winning. Okay, so let's just start building this up. You win $8 for rolling a 3 or a 4 out of 6. That means 2 numbers out of 6 numbers, so equals 2 out of 6. That's the probability for winning. Because it says you're rolling a 3 and a 4, and if you roll those 2 numbers, you win $8. But those are 2 numbers out of altogether 6 numbers, so the probability of winning will be rolling those 2 numbers out of 6 numbers, so it'll be 2 out of 6. That's the probability of winning. And otherwise, you'll lose that original $5 wager, so -5 will be your loss. And the other probability, there's no information for that, but you know that the sum of the probabilities always has to add up to 1. So that missing probability will just be 1 minus the previous one. You see, now they do add up to 1. And once you calculate, and that is the probability distribution there. And now you want to calculate the expected value, you have to calculate the XP's, which is basically X times P. and it's easier to just type it than drag it down on an iPad. So I'm just gonna type it. There we go. So those are my XPs, and if I add them up, I get negative 0.666666, and that's my expected value. That's my mean. Of course, I have to write it here, so I can just say equal to that number, and it will bring it there, and that's my expected value. Thank you, and I'll see you guys on the next video for the next 5 questions for Module 4. Thank you.